In these video notes, we're going to break down what a system of equations actually means, along with dealing with some word problems on the back side. So a system of equation, you'll see that you'll have a grid with two different lines. So this is kind of an introduction. We're supposed to write an equation to represent each person's line. So when we write an equation, it always has to be in the y equals mx plus b form. So for Ace, he starts at 2, so that's my y-intercept. And then I can see that all of his points, I have to go up 1 and over 1. So that means that my slope would be 1 over 1 or just 1. So I would have y equals, my slope is 1. So I can put a 1 in front of my x if I wanted to. I don't have to. And then my b is my y-intercept. So it started at 2. So y equals 1x plus 2. For Annie started at 8, and then she went down 1 and over 1 to get to all of her points. So that would show a negative 1 over 1 as a slope. So this would be a negative 1 slope. So y equals negative 1x plus 8, because again, she started at the 8. On part B, it says list the ordered pair where the lines intersect. Ordered pair means that that's a coordinate point, and the intersection point is where the two lines cross. So this point is where the two lines cross, and that is at 3, 5. So an ordered pair is always at a coordinate point where I put my parentheses with my x number and then my y number. On part C, it says, is the point above a solution to Ace's equation? Give two ways you can tell. So on Ace's equation, that point is a solution because it lands on the line. And it also makes the equation true. And I'm going to explain that in just a second. So Ace's equation is y equals 1x plus 2. Well, my y value is 5. So instead of my y, I plugged it in for my 5. I would have equals. My 1 doesn't really matter, so I'm not going to worry about that too much. My x number is 3. And then I have this 3 plus 2. Well, I know that 3 plus 2 equals 5, so it does make this equation true. So the x and y numbers, when I plug them back into my equation, it makes the equation true. It's the same thing for Annie. So for Annie's points, that point lands, again, on the line. And then it will also make the equation true, whatever Annie's equation is. So if Annie's equation is y equals negative 1x plus 8, instead of my y, I'm going to plug in my 5. Instead of my x, I'm going to plug in my 3. Well, negative 1 times 3 is negative 3, and negative 3 plus 8 would equal 5. So that is true as well. So the main thing about a system of equations is that a system of equations is a set of more than two equations with the same variables. The point of intersection of two graphed equations is the solution of the system of equations. So on this first example, we're going to do the same type of thing that we did above. We're going to write the equation. So my line A starts at 0, and then if I find my points on line A, I'm going to go up 2 and over 3. So I would have 2 over 3x plus 0. I don't have to add that 0 in there. On B, it starts at 2, and then every point goes up 1 and then over 3. So up 1 over 3, so 1/3 x, and then I have plus 2 at the end. My solution point is where my point of intersection is. So this is my solution that I'm looking for. So at that solution point, it's always going to be a coordinate point. So I'm going to write the number 6, 4. So 6, 4 is going to be a solution. So when I prove my work, so if I do A, I would have my equation. And instead of my x and my y, I'm going to plug in these numbers. So my y number is 4. And my x number is 6. If I take 2/3 times 6, it will equal 4. I can type that into my calculator. And then same thing for B. If I have my equation, but instead of my x and my y, I can plug it in. So my y number is 4. My x is 6. 1/3 times 6 is going to be 2. And then 2 plus 2 equals 4. So that works as well. On the last one, it says record if each ordered pair below is a solution. So a solution, remember, is a point that lands on the line to equation A, equation B, or neither. So 3, 2. If I find 3, 2 on my graph, 3, 2, that is only one that lands on A. If I find 4, 6, that point does not land on either, so that would be neither of the lines. If I find 3, 3, that would be only on line B. And then 6, 4 again is our solution point, and it works for both of the lines. All right, turning paper over. On this backside, we're going to graph our lines. So this is our two equations that we're going to graph on this one graph. So I'm going to start at 3. And then if I have a negative 1/2 slope, my negative sign is always going to go with that top number. So I'm going to go down 1 and then over 2. And I'm going to continue that pattern. I can reverse it. Instead of going down 1 and to the right 2, I can go up 1 and to the left 2. So that is what my first line is going to look like. My next line, if you look at this, it's y equals 5. There's no x. So that's kind of saying that if I had a 0x there, if I have a 0 slope, that means it's a horizontal line. And I know that my y-intercept is going to be at 5. So I have a horizontal line that goes through 5 on the y-axis. My solution point is where my two lines cross, which would be at -4, 5. I'm not going to worry about the check. We'll work on that at another time. On this next one, I am going to start at -2 as my y-intercept. I'm going to go up 1 and to the right 3 to find my solution points. On my next one, I'm going to start at 2. If I have a x with no numbers in front, that means it's going to be a negative or a 1. And in this case, it's going to be a -1. I can turn that -1 into a fraction by putting a 1 underneath it. So I'm going to go down 1 and to the right 1. Down 1 and to the right 1, and I'm going to continue that pattern until I either find a solution point or I run out of room. So my solution point is right here. It's going to be at 3, -1. So graphing basic lines like this is one thing, but a whole nother ballgame is putting context to the actual graph itself. So on number 4, it says the total cost of 2 t-shirt companies based on the number of shirts ordered is shown below. We have company A, we have company B. We have to write an equation to represent each company. So I need an equation for company A, and I need an equation for company B. Company A starts at 0. See, this is company A. I start at 0, so if 0 shirts will cost $0, and I'm going to go up 3, so I'm going to increase by $3 for every 1 shirt. So I'm going to go up 3 and then over 1. So that means that my slope is 3x. And then I can put a plus 0. I don't have to put a plus 0 if I don't want to. On company B, I start at 6. And I'm going to go up $3 for every 3 shirts. I'm going to go up $3 for every 3 shirts. So that means each shirt would cost $1. So $3 for 3 shirts. So my slope would be 1x and my y-intercept would be 6. The next question, it says how many shirts would need to be ordered for the cost to be the same, there's our key word, same, of either company. So if I want something to be the same, that means that it has to be equal. And I am looking at this solution point right here. So for 3 shirts, it is going to cost $9. So 3 shirts cost $9. So if I only want to get 3 shirts, it doesn't matter if I go with company A or company B, because regardless, it's going to cost the same. On the last question, it says if Justin needs to order 5 shirts, which company would be cheaper? Which would be the cheaper option? So if I look closely at my graph, I'm looking for the number of shirts. I want 5 shirts. If I go with company B, it would be around $11. If I go with company A, it would be around $15. So I want the cheaper option, so I would go with company B. All right, your job is to work on this last problem by yourself.